Thank you.
Uh, let's get this open. How's that look? Everybody can see it?
Yes, I can see it.
Great. Okay. So for my topic, I chose to look at something that's very related to what I'm studying here at URI. I'm in the MESM department. I study wetland, watershed, and ecosystem science. So I decided to take a look at wetland mapping techniques using remote sensing and GIS. So first, to understand wetland mapping, we need to understand this coordinate classification system, which is something that people are probably familiar with if they're in the environmental science world. If not, this is a really basic introduction to it. So it was developed by the US just as a way to help classify wetlands. And they use these three indicators, which are hydrology, hydric soil, and hydrophytic vegetation, which I'll define in a second. But I use these three indicators to kind of create a framework for my research. So I went through and figured out ways that we use remote sensing to find each one of these three indicators. So starting with hydrology, that's the easiest one. That's literally just the presence of water. And so in order to understand how we use remote sensing to find the presence of water, I looked at the National Wetlands Inventory, which does exactly that. I reviewed this technical manual, which is basically just a summary of how they produce the National Wetlands Inventory. And they do that by looking at aerial photographs at a 1 to 58,000 scale. They use humans to digitize wetlands by hand, just looking for, like I said, hydrology. They're just looking for standing water. And they're limited to wetlands that are greater than 1 acre, just because of the scale of the photographs and because of the amount of work it would take to do anything smaller than that. Next, we have hydric soil, which is just soils that have formed under wet conditions. And so in order to learn some more about how we use remote sensing to find hydric soils, I looked at this Swedish study that was looking into trying to predict areas that are flood prone along roads, railroad tracks, things like that. And so they found that the best way to find hydric soil using remote sense data was with these European METOP satellites, specifically the ASCAT sensors on them. And these satellites are cool because there's actually 3 of them that are constantly orbiting. And so they have a really good temporal coverage. As you can see, it's about 82% of the globe is covered by these satellites every day. And these give you really accurate data about soil moisture content. They can actually tell you exactly how much moisture in volumetric units is in soil. They also use the SMOS satellite, the MIRA sensor on it. This one's less ideal, but it works really well for when there's a lot of trees or other vegetative covering over the soil. And this is less ideal just because it can really only see the surface of the soil. So if there's a deeper water table, it's not really going to be able to see that very well. Next, we have hydrophytic vegetation, which is probably the most difficult, and also there's the most kind of amount of research out there. So I read a ton of papers on this one. And sorry, I forgot. Hydrophytic vegetation is just plants that only occur in wetlands. So those are going to be our obligate species. So one of the papers I found that kind of helped break it down for me, just because there was so much information out there, was this review of multispectral and hyperspectral remote sensing being used to find wetland vegetation. And what this one paper was saying was that satellite data is really too coarse to be used to delineate between species of wetland and upland vegetation. They were saying that it just doesn't have the spectral or the spatial resolution to really look in and find the differences between some of these plant communities. It can be used for monitoring the quantity of these plants and also just for monitoring changes in them over time. This paper recommended to continue to use aerial photography just because of the higher spatial and spectral resolution that you can get from it, although it might not be good for larger scale studies. it's really effective in finding the more specific details or specific lines between vegetation communities. And that is it. I don't have a conclusion slide, I'm sorry, but thank you all for listening.
All right, thank you, Andrew, very much. And then let's see. Okay, just on time. Thank you, everyone, for keep the presentation on time. Next,